Question number 13. A rod is pivoted at one end. So the rod is pivoted at one end, that is at this end. Initially the angle theta of the rod to the horizontal is 0. That means in respective to the horizontal, the angle of the rod is 0, that is at 0 degree. The weight of the rod causes a moment m about the pivot. So the weight of the rod that is obviously acting at the center causes a moment m about the pivot. And what is the moment? We know that moment of force is the product of force and the perpendicular distance from the pivot to the line of action of force. That means basically the moment of force is the product of perpendicular force and the distance from the pivot. So the force have to be perpendicular force with respective to the pivot. So the force have to be perpendicular with respective to the pivot. Then the rod is then rotated in the vertical plane so that the angle theta of the rod increases from 0 degree to 180 degree, which graph shows the variation of moment with theta. So we need to find which graph is the moment against theta. So at 0 degree, we can see that with respective to the pivot, the force is perpendicular. So, and there is some distance. So obviously there is some moment. Then at 180 degree, that means at 90 degree, when the rod is at 90 degree with respective to the horizontal, when the rod is 90 degree, the weight is acting vertically downwards. And here we can see that with respective to the pivot, the force is not perpendicular, the force is parallel. With respective to the pivot, the force is parallel. Therefore, the moment is 0. Since there is no perpendicular force, therefore the moment is 0. That is, moment is 0, moment 0 and moment 0. There is no 0. Therefore, this option is wrong. Then, when at 180 degree, that means the rod is at the other end, we can see that there is a perpendicular force with respective to the pivot. There is a perpendicular force and obviously there is some distance from the pivot. Therefore, there is some moment. So, in all of these three options, there is some moment. But we need to find that which option is correct. So, initially at 0 degree, if we see, then with respective to the pivot, the weight is acting downwards. So, there is a clockwise moment. And at 180 degree, with respective to the pivot, with the weight is acting downward, so there is an anticlockwise moment. So the clockwise moment, if we consider the clockwise moment as positive, then the anticlockwise moment must have to be negative. So the anticlockwise moment is negative. Therefore, the option should be either C or D. This is not B. Then the anticlockwise moment is negative. Then whether the option should be C or D. So first of all, if we consider the angle of 45 degree, that means the rod is at an angle of 45 degree, then the weight is acting vertically downward. And if we break the weight into its component, that is the vertical and the horizontal component, then this component is W cos 45 and the horizontal component is W sin 45. And what is the moment? So moment of force is the product of force and the perpendicular distance from pivot to the line of action of force. So the force have to be perpendicular. Therefore, we have to consider the perpendicular force with respective to the pivot. So the perpendicular force is W cos 45. So W cos 45. So this is the moment that comes. So here we can see that this is the cos graph. So cos graph is not a straight line. This is not a linear graph. This have to be curved. So the option should be D. And so the option is D. But for the cos graph and sine graph, you must have to remember that the cos graph, instead of starting from 0, it starts from a higher value. That is, if we press cos 0, it gives a value of 1, that is a higher value. But the sine graph always starts from 0, that is, if you place a sine 0 at the calculator, then it gives us a value of 0. That means the sine graph always starts from 0, but the cos graph starts from a higher value. So this is the case.